All right, everyone, welcome back for another deep dive.
Yeah, thanks for having me.
Today we're talking about something that's, it's sort of a hidden engine that's behind, almost everything that we use every single day.
Right.
You wake up in the morning, you check your phone, you're using apps, you go on the internet, you're browsing websites,
Right.
and there's this kind of invisible force that's behind all of it.
Yeah, most people don't really think about what goes into the software that they're using.
Exactly.
But a lot of it is built on open source software.
Exactly. And we're talking about open source software, or OSS.
OSS, yep.
And just to give you a sense of just how prevalent this is,
Okay.
we're going to be looking at this fascinating new working paper
Okay.
called The Value of Open Source Software by Manuel Hoffman, Frank Nagel, and Yanyu Zhu.
All right.
And just to kind of kick things off, they revealed that OSS is found in something like 96% of code bases.
Wow.
And here's another really interesting statistic. Some commercial software can be up to 99.9% open source.
That's huge. That's most of the code.
Yeah, it's almost all of it in some cases.
Oh.
But here's the thing that this paper tries to grapple with.
Okay.
It's really hard to put a value on open source software.
Right, because it's free.
Exactly. It's often free to use.
Right.
There's no central tracking system.
It's just out there.
Right. And so you can't just do the traditional economics of like price times quantity.
Right. That breaks down.
Exactly, because the price is often zero.
All right.
And the quantity is kind of unknowable.
Yeah, you don't know how many people are using it, where they're using it.
Exactly. So our goal in this deep dive is to try to understand and uncover this hidden value of open source software.
Okay, sounds good.
And to do that, we're going to be looking at this working paper that uses some really unique global data.
Okay.
To try to put a number on something that's very hard to put a number on.
Right.
The two main data sources that they looked at were the Census TUSIC of free and open source software application libraries.
Okay.
And the built with data set.
All right. So we're going to see how much open source software is used.
Exactly. And trying to figure out, okay, well, what does that actually mean?
What does that mean?
In terms of its value.
Right.
But to even start to think about this, it's helpful to think about this kind of broader economic context.
Okay, sure.
So the paper brings up this idea of the commons.
Right.
This idea goes all the way back to Aristotle.
A while ago.
Yeah.
Yeah.
Yeah. He observed that which is common to the greatest number gets the least amount of care.
That's interesting.
Yeah.
Something that everyone can use, no one ends up taking care of.
Exactly. And this idea has been picked up by various thinkers throughout history.
Yeah.
William Forster, Lloyd, Garrett Hardin, more recently in his essay, The Tragedy of the Commons.
Right. Yeah, I heard of that one.
Yeah, and it's this basic idea that when you have a shared resource, there's a risk of overuse and underinvestment.
Right, because you don't bear the full cost.
Exactly. Yeah, if you're just one person out of millions using something,
right,
you don't really feel the responsibility.
Right, no one's going to notice if I use a little bit more.
Exactly.
Yeah.
And so this is directly relevant to open source software.
Okay, I see.
Because you have this vast shared digital infrastructure.
Yeah, the internet basically runs on it.
Right. Everyone benefits from it,
yeah.
From huge corporations down to individual users.
Right.
But the responsibility for maintaining it,
who's going to do that?
Is kind of unclear.
That's true.
And the paper even quotes Lord Kelvin.
Okay.
He said, if you can't measure it, you can't improve it.
That makes sense.
So if we want to think about the long-term health of open source software, we need to be able to put some kind of value on it.
We need to figure out how important it is.
Exactly.
Yeah.
Now, this isn't the first time that economists have tried to do this. There have been attempts to figure out what's the labor replacement cost. Okay. So, like, if we had to rewrite all the open source software
from scratch,
how much would that cost?
Okay.
And they mentioned some studies that came up with some numbers like $38 billion for the U.S. in 2019 and €1 billion for the EU in 2018.
So it's a lot of money, but how do they know?
Well, and that's the thing, is that those studies kind of make some broad assumptions. They assume that like all open source software is equally valuable.
Right.
And that you would only need to write it once.
Okay.
But in reality, if open source didn't exist, all these different companies would probably be recreating the same things.
Oh, so there'd be a lot of duplication.
Exactly. There'd be a lot of wasted effort.
Yeah. That makes sense.
And so it's not really capturing the full picture.
Yeah. It's like saying, okay, well, how much would it cost to build all the roads in the world?
Right.
But you're not counting the economic activity that those roads enable.
Exactly.
Okay.
There have also been some studies that have looked at very specific
okay.
open source projects.
Okay.
Like the Apache and Nginx web servers.
Right. Those are pretty popular.
Yeah, those are very widely used.
Yeah.
And those studies tried to figure out,
okay.
What would be the cost of a proprietary alternative.
Okay.
And they also looked at how widely they were used on public websites.
All right.
And those studies found that just those 2 web servers were worth billions of dollars.
Whoa, just those 2?
Just those 2.
Okay.
But as this paper points out, web servers are just one small piece of this whole open source ecosystem.
There's so much more.
So how did this new working paper try to kind of get a more comprehensive picture?
Okay. Yeah. How did they do it?
Well, they looked at these 2 data sets that are kind of unique and complementary.
Okay.
So the first one is Census the second.
Okay.
And this involved working with several software composition analysis firms.
Okay.
So these are companies that businesses hire to scan their code.
Okay. To see what's in there.
Yeah, essentially.
Okay.
And the main reason they do this is to make sure that they're complying with the licenses of the open source software that they're using.
Oh, that makes sense. Yeah. Because you can't just use anything.
Exactly.
You have to follow the rules.
Yeah. There are different types of licenses for open source software.
Right.
And you have to make sure that you're following those rules.
Okay. So these SCA firms are basically keeping track of what open source software companies are using.
Yeah. As a kind of byproduct of doing this license compliance.
Oh, that's a clever way to get the data.
Yeah. And so Census the second took all this data from thousands of companies around the world.
Worldwide.
And they had something like 2.7 million instances.
Wow.
Of OSS packages being used.
Okay.
And this is all in the calendar year 2020.
Okay. So just a snapshot in time.
Exactly.
But still a lot of data.
Yeah. A huge amount of data.
Yeah.
And what's really interesting is that they captured not just the OSS that the companies were directly using, but also the dependencies.
The dependencies. Okay.
So the other bits of open source code that those packages rely on.
So it's kind of like you buy a car.
Right.
But then the car has all these parts. That it depends on.
Exactly. And you might not even know.
Right. You don't know where they came from.
You know where the tires came from or,
the engine or whatever, right?
Yeah, exactly.
Okay.
And so to kind of make sense of all these different OSS packages.
Yeah.
They standardized the naming using libraries.io.
Okay.
Which is a website that a lot of developers use.
Okay, yeah. That makes sense.
And then they focused on the top 2,000.
Okay.
Those widely used packages.
All right, so the most popular ones.
Exactly.
Okay.
And so that includes the top 1,000 from the Node Package Manager.
Okay.
Which is very popular in JavaScript.
Right.
And then the top 1,000 non-NPM packages.
Okay, so they got a good mix.
Exactly.
Okay.
And so that gives us a sense of the inward-facing usage.
What inward? Okay.
So what companies are building into their own system.
Right, into their own products.
Exactly.
Okay.
But then the other side of that
yeah.
is the outward-facing.
The outward, okay.
So what's powering the websites that we see?
Right. The stuff that we actually interact with.
Exactly. And that's where Built With comes in.
With, okay.
So Built With is a company that constantly scans millions of websites.
Millions, wow.
Yeah, almost 9 million websites.
Okay.
To figure out what technologies they're using.
Okay, so what's running under the hood?
Exactly.
Okay.
And that includes open source libraries.
Right.
Now, the Built With data doesn't say, like, this is open source or this is not.
Okay.
So the researchers decided to focus on JavaScript and its libraries.
Mm-hmm. Okay. JavaScript. Why JavaScript?
Because JavaScript is so fundamental to the web.
It is. Yeah. Almost every website uses it.
Yeah, exactly. Mm-hmm. And it's heavily used in open source projects.
Okay. So it's a good proxy.
Exactly.
Okay.
And so by looking at the JavaScript libraries that are being used, they could get a sense of how much open source software is being used.
Okay. On websites.
On websites, yeah.
Yeah, that makes sense.
And they wanted to make sure that they were capturing private sector usage.
Okay.
So they cross-referenced the website domains with company records.
Oh, so they made sure it was like a business.
Yeah, like a real business.
Okay.
And they used databases like Orbis, Compostat, and PitchBook.
Okay.
And they filtered out non-commercial sites.
Okay.
So this gave them a huge data set of OSS usage
by
businesses.
All right, so that's the outward facing.
Yeah, exactly. And again, this is all focusing on the period around 2020. So these two data sets are really kind of looking at two different sides.
Two sides of the same coin.
Exactly.
Oh, okay.
So you have Census the Second, which is showing what's being built under the hood.
Right.
And Built With, which is showing what's powering the websites that we see.
Okay, cool. So that covers a lot of ground.
Yeah. And it minimizes the chance of double counting.
Right. You don't want to count the same thing twice.
Exactly.
Okay.
So with all this data on how much OSS is being used.
Okay, the quantity.
Yeah, the quantity.
Right.
They then had to figure out, okay, well, what's the price?
Right. Or the value somehow.
Yeah, or the value more accurately.
Okay.
And they used two main methodologies for this.
Two methodologies.
Yeah.
Okay.
So the first one is the supply side value.
The supply side. Okay.
And the basic idea here is, what would it cost to recreate these widely adopted OSS packages?
Right.
If they had to be built from scratch.
Okay, so just once.
Just once.
Okay.
And to answer that question,
they
look at the number of lines of code.
Okay. The raw size?
The raw size in the software.
Okay.
And then they use the constructive cost model 2.
Kokomo 2.
Or Kokomo 2.
Oh.
Yeah.
Okay.
And this is a model that's used in software engineering.
Right.
To estimate the effort and cost. Involved in developing software.
Okay.
And it considers things like project complexity,
right,
the required reliability,
okay,
the experience of the team.
So all the things that go into making software.
Exactly.
Okay.
And so they're taking the size of the software,
okay,
and they're plugging it into this model.
Yeah.
And they're saying, okay, this is how much time and effort,
right,
it would take to write this code.
Okay.
And then to translate that into dollars.
Right, because time is money.
Exactly.
Yeah.
They used global wage data for software developers from Salary Expert.
Okay.
And they focused on the top 30 countries.
Okay.
With the most GitHub developers.
So where all the programmers are.
Exactly.
Okay.
And they even developed scenarios where they used like a low wage and a high wage.
Okay.
And they used India for the low wage.
Right.
And the U.S. for the high wage.
Makes sense.
Just to get a range.
Yeah, a range of possible values.
Exactly.
Okay.
So when they crunched all those numbers for the supply side.
Okay.
They found that using the global average wage.
Okay.
The cost to recreate all this widely used open source software.
Yeah.
Would be $4.15 billion.
Okay.
Now, they point out that this is just the most prevalent OSS.
Right.
So if you compare that to those earlier studies that tried to value all OSS,
right,
which came up with much larger numbers,
right,
this is kind of a lower bound.
A lower bound, okay.
Because they're only focusing on the stuff that's actually being used.
Right, the stuff that matters.
Exactly.
Okay.
So that's the cost to build it once.
Right, but that's not the whole story. Because it's used over and over.
Right. The real value comes from how much it's used.
The usage.
Yeah, the demand side value.
Demand side.
Okay.
Yeah.
And so to estimate that, they took that initial supply side cost.
Okay.
And they scaled it.
Okay.
Based on the usage data from Census to Second and Built With.
Okay, so they said, all right, well, if it costs this much to build it once, how many times is it being used?
Exactly.
Okay.
And the basic idea here is that if open source didn't exist,
right,
all these companies would have to develop all this functionality themselves.
Themselves, yeah. Okay.
So they're basically taking the cost to create it once.
Right.
And multiplying it by the number of times it's being used.
By all these companies and all these websites.
Exactly.
Okay.
And so when they did that.
Yeah, what did they get?
Using the global average wage.
Okay.
They estimated the demand side value to be $8.8 trillion.
8.8 trillion.
Trillion with a T.
That's an insane number.
It's a huge number.
Yeah. How do you even contextualize that?
Well, they tried to put it into perspective.
Okay.
So they compared it to the total global software revenue in 2020.
Okay.
Which was something like $531.7 billion.
Okay.
So much smaller.
Yeah, way smaller.
And they also looked at estimates for the value of prepackaged software.
Okay.
And even broader figures for private sector investment in software.
Right.
And their analysis suggests that without open source, companies would have to spend about 3.5 times more on software
than they do now. Wow.
So that's the leverage that open source is providing.
Yeah, it's like a force multiplier.
Exactly.
Okay.
Now, the paper also looked at how this value varies across different programming languages.
Yeah.
And so on the supply side, they found that Go, JavaScript, and Java had the highest estimated costs to recreate.
Okay. The most expensive.
Yeah. But interestingly, Python.
Python.
Which is very popular.
It is, yeah, very popular.
Yeah.
Especially for data science and AI and stuff.
Exactly.
Okay.
It had a lower supply side value.
That's interesting.
Yeah. Why do you think that is?
I don't know. Maybe the packages are smaller?
Yeah, maybe they're simpler.
Maybe there's fewer lines of code?
Yeah, that's possible.
Okay.
But then when they looked at the demand side.
It's the demand side. Okay.
So the value from usage.
Right.
The picture changed a bit.
Okay.
So Go's demand side value was way higher.
Okay.
It was more than 4 times that of JavaScript.
Wow.
Which came in second.
Okay.
And then TypeScript. Which is related to JavaScript.
Right. It's kind of like a newer version.
Yeah, it's kind of a newer, better version.
Yeah.
It also had a very high demand side value.
Okay. So it's being used a lot.
Yeah. A lot of people are using it.
Okay. Yeah.
So it seems like these different languages play different roles.
Different roles? Okay.
Some are more expensive to develop initially.
Right.
And some are more widely adopted.
Okay.
They also broke down the OSS value by whether the usage was inward facing.
Okay.
From the census data.
Right.
Or outward facing.
From built with.
From built with.
Okay.
And they found that languages like Java, C, Python, and TypeScript.
Okay.
Their supply side value was mostly driven by the census data.
Okay.
So that suggests they're being used a lot in internal software.
Enterprise software.
Enterprise software, yeah.
Okay.
Whereas JavaScript and TypeScript were the dominant contributors to both the supply and demand value from the built with data.
So for websites.
For websites.
Okay, that makes sense.
Yeah, and that makes sense because JavaScript and TypeScript are used a lot in web development.
Right. For front end stuff.
Yeah, exactly.
Okay.
So they also looked at the demand side value of OSS across different industries.
Industries, okay.
And they used the built with data for this.
Okay.
And they found that professional, scientific, and technical services had the highest usage value.
All right, so like consulting firms.
Yeah, consulting firms.
Okay.
And then retail trade.
Retail. Okay.
And administrative and support and waste management and remediation services.
What's a mouthful?
Yeah, that's a long one.
Okay.
And then on the other end of the spectrum,
yeah,
you had industries like mining utilities and agriculture.
Okay.
That had much lower usage value.
So the more traditional industries.
Yeah, the industries that maybe aren't as reliant on software.
Right. They don't have as much of a need.
Exactly.
Okay.
So it seems like open source is particularly important.
Yeah.
For knowledge-based and customer-facing industries.
The ones that are really driven by software.
Exactly.
Okay.
Now, one of the most interesting findings of this paper is about the concentration of value creation.
Okay.
So they wanted to know who's actually creating
all
this valuable open source software.
Right. Who are the people behind it?
Exactly.
Okay.
So to figure this out, they used the GHTorrent database.
GHTorrent. Okay.
Which tracks activity on GitHub.
GitHub, right? That's where all the code is.
Yeah, that's where all the open source code is.
Okay.
And they looked at developer contributions.
Okay.
Which are measured by the number of commits.
Commits. Okay.
So commits are basically changes to the code.
Okay.
That developers submit.
Right. They're like, okay, I made this change.
Yeah, exactly.
Okay.
And they were careful to filter out contributions that are made by bots.
Oh, right. Because some of that is automated.
Yeah, there's a lot of automation in software development.
Okay.
So they wanted to focus on the human effort.
Okay, just the people.
Yeah.
Okay.
And what they found was pretty striking.
Okay.
They used Lorenz curves.
Lorenz curves.
Which are a way of visualizing how something is distributed.
Okay.
And they found that the distribution was very skewed.
Skewed. Okay.
So on the supply side,
the
top 5% of programmers were responsible for 93% of the value.
93%?
Yeah.
Wow, so a tiny fraction.
A tiny fraction of people are creating almost all of the value.
That's crazy.
Yeah. And then when they looked at the demand side.
The demand side.
So taking into account how much the software is being used, that top 5% accounted for over 96% of the value.
Wow, even more.
Yeah.
Okay, so it's like a superstar system.
Yeah, a very small number of people are having a huge impact.
A huge impact.
Wow. And what's also interesting is that these top contributors, they weren't just working on a few projects.
Okay.
They were contributing to lots of different repositories.
So they're spreading their expertise around.
Exactly.
Okay.
So this has some pretty big implications.
Yeah, what does this mean?
Well, it means that we're very reliant on a small group of people for this critical infrastructure.
What happens if they stop?
Exactly.
Or if they get burned out?
Yeah. What happens if they decide to go do something else?
Right.
And the paper highlights some of these implications.
Okay.
So first they say that this study is the most comprehensive estimate yet of the value of widely used OSS.
Okay, so it's the best number we have.
Yeah, the best number we have so far.
Okay.
Second, they emphasize the importance of these new data sources.
Dissensus and built with.
Yeah, exactly. As indicators of investment in intangible capital.
Intangible capital. Okay.
Yeah, so basically investment in software.
Right, because it's not like a physical thing.
Exactly.
Okay.
And then third, they stress the importance for companies that rely on open source to contribute back.
Oh, yeah, to give back to the community.
Exactly.
Okay.
Because they're getting all this value.
Yeah, for free, basically.
Yeah, for free.
Okay.
And it's a relatively small investment.
Yeah.
To ensure the long-term health of the ecosystem.
Right. Keep it going.
Exactly.
Okay.
And then finally, they emphasize the implications for policymakers.
Policymakers. Okay.
Yeah. So they're saying that policymakers need to be aware of the economic significance of OSS.
Right. It's not just a hobby.
Yeah. It's a huge part of our economy.
Yeah.
And they need to think about policies that support its development.
Right. To make sure it keeps going.
Exactly. And crucially, they need to support the people who are creating it.
The developers.
The developers, yeah.
Okay.
Because as we've seen, a very small number of people are responsible for a huge amount of value.
A huge amount.
So, it's easy to think of open source as this free resource.
Yeah, it's free to use.
But it's not really free.
Right. Someone has to write the code.
Someone has to write the code. Yeah. Someone has to maintain it.
Someone has to fix the bugs.
Exactly.
Yeah.
And so this paper really highlights the true cost.
Yeah, the true value.
Or the true value, of open source software.
And it's a lot.
$8.8 trillion.
It's a lot.
And it also highlights the fact that this value is concentrated in the hands of a few.
A very few.
Yeah.
Okay.
So it's a really interesting paper.
Yeah, it is. It's a lot to think about.
It's a lot to think about, and it raises a lot of questions.
Yeah.
So if you're interested in learning more,